Hello, fellow foodies. This is Dr. Cassandra Quave, your host for Foodie Pharmacology, the science podcast for the food curious. This week on the show, we're talking about spirulina. It is an edible biomass of cyanobacteria, also known as blue-green algae. Spirulina is a popular food supplement that is rich in a number of nutrients, including vitamin B1, B2, and B3, as well as copper, iron, and protein. A number of scientific studies have shown that spirulina exhibits antioxidant, anti inflammatory, and neuroprotective effects. Interestingly, it's noted that the Aztecs and other Mesoamerican peoples actually used spirulina as a food source until the 16th century. But today, we're going to be talking more about the modern uses of spirulina and its applications in our current day food culture. I've invited Jonas Guenther to the show. Jonas is an entrepreneur, a food activist, and a writer. He started developing solutions to grow food during his graduate program at NYU, guided by the question of how do we need to change the way we grow, ship, and eat food to make it carbon neutral. Jonas established an experimental farm in the School of Engineering, which serves as a project platform that enables students to learn about sustainability and food by running their own mini projects, connecting their studies to the world of farming. This would eventually lead him to the launch of We Are the New Farmers. Deeply passionate about creating a livable future, Jonas has also started the magazine Fighting Tomorrow, which offers a glance into a world where we have overcome climate change and implemented solutions to make the future of food exciting. He began his career as product manager at Olympus and has been recognized by the city and state New York as one of the responsible 100. He continues to work with the NYU entrepreneurial community as a mentor and founder in residence and as a mentor for Start Out. So thank you so much for coming on the show, Jonas. It's really great to meet you.
Thank you so much for having me. Wow, what an introduction, huh?
Well, I think it's really exciting. I love this theme of entrepreneurship and also thinking about how can we take these historic practices going back centuries, right? And bring it into the modern food industry. I know one of your passions is really focused on sustainability and creating a sustainable food system. So why don't we start there? Like, why is it important to have a sustainable food system?
Yeah, I mean, that's a very good question, but like really the question is what would happen if we wouldn't have a sustainable food system? And that's what we're living in right now, right? And that is that we just all suffer from a variety of problems, and that is that the food that we produce isn't delivering the nutrients that we need. It destroys the environment we're living in, from deforestation to the killing of insects to the enormous impact that we have from a carbon perspective and freshwater perspective. We are desperately needing solutions to make our food system more sustainable and get to that point, because we're at the point right now where we continue like this for another decade or two, then there probably is not going to be another planet.
Yeah, no, I totally agree. We have to take more action both to preserve our existing biodiversity, but also to think about ways to leverage sustainable food systems to feed the world, right? So let's dive in a little bit more into spirulina because I'm sure that many of the audience members have heard of this product or of this blue green algae, but they probably don't know much about how it became a food and what its kind of health properties are. Maybe you can give us a little bit of a background on spirulina.
Yeah, sure. So, spirulina is a type of algae. So that means it's in the same family as seaweeds like kelp or nori, but it's a microalgae, which means it's microscopic. It's much smaller. It is packed with nutrients and vitamins. It's a really good source of plant-based protein and a variety of vitamins and minerals, as you already mentioned in your introduction. It's often considered, a superfood. I don't necessarily agree with these kind of terms, but just to give people a perspective of the nutrient density that gives people. It's extremely well researched for the past 40 years since it's been introduced in the Western world. Countless studies have been done on it, on the health benefits for humans. NASA has been doing a lot of research on it because they consider it one of the foods that they want to send on long distance space travel, because it is such a complete source of vitamins, nutrients, protein, and can be cultivated with minimal resources. But at the same time, it's also this super fascinating organism because it is quite literally the oldest food source ever. It's like 3.6 billion years old. That's billion. That means like it's primordial soup old. Um, and this type of organisms, cyanobacteria, are actually the reason why we have oxygen on the planet. It's the first photosynthetic active type of organism that's been around. And what that means is because it's so incredibly old, the metabolism is incredibly efficient. So it knows exactly what to do with almost nothing available. They're really efficient machines that turn like carbon as well as base nutrients or base salts into the building blocks of life, from fatty acids to proteins to carbs and everything else, which makes them super interesting for today, for a path forward into a more sustainable future.
That's great. And so when we think about spirulina from a larger market perspective, just how big is trade in this organism? Like how big of a deal is this for the human dietary industry and the animal industry? I know it's used in a number of different ways.
Yeah, it's rapidly growing, and the reason for that is that we increasingly find new applications for it. So traditionally, spirulina is something that has been grown overseas. Like it's a algae that really loves tropical climate. So it grows in Southeast Asia, or it's cultivated today in Southeast Asia and India and China. And it's then dehydrated into a powder, which is the most common form in the image that you just showed here. So it looks like a dark green powder that people use in juices and smoothies. It's a very common nutrient supplement, but it also has some downsides to it. This type of powder, it's a little bit bitter. It's actually infamous for its rather bad taste, and it's a powder, so it's not really a food. People don't think of it as a food. They think of it as something that's an additive to the things that they make as a supplement, but not really as a food. The industry has been dealing with a lot of issues in terms of contamination and purity of the products. It's generally rather a low quality product these days. And despite all of this, it's still a hundreds of $1 million market just in the United States, and even bigger beyond. And that brings me kind of to today, where the industry is heading towards, and that is that people realize what a fascinating organism spirulina, but also other types of microalgae are, and what kind of potential it has. Because we can cultivate that stuff and grows extremely fast, and we can use that almost as biofactories that can basically just provide whatever we want, and take out what we need. There are lots of companies that try to isolate protein from it, or that try to isolate certain pigments from it to create dyes. So it's a rapidly growing industry, and there are more and more applications in food, in fertilizers, in biofuels, in bioplastics. It's growing and growing and growing. And what we do, essentially, what we're kind of the next step, and what separates us from that, is that we started out with this powder, and that's what you've seen. But we really believe that we are the new farmers, that food needs to be fresh. Like good food is something that should go bad eventually. And so we developed a tech that allows us to grow food much closer to where we live. So we don't end up with a dehydrated powder, but rather a fresh and unprocessed product, which has better flavors, better nutritional availability, higher nutrient content, and just generally more versatility, so that people can actually start using that as a food ingredient like people have used it like centuries ago.
That's really interesting. Yeah, that's a great point too. Is I'm sure the flavor of the powdered dehydrated product is going to be very different from the fresh product. And historically, it was consumed, I believe, fresh. Although maybe they dried it as well. I don't know what they know from an archaeological perspective on that. Um, but what can you share with us about the technologies to cultivate this in kind of a closer to home setting? I'm assuming you're talking about some sort of aquaculture that can be done indoors, or in ponds, tanks. Like how does this all work? Yeah.
Historically, it's been something that's been harvested in the wild. It naturally occurs in lakes in Africa, around Lake Chad, as well as in Mexico, in the Lake Texcoco, which is the lake complex that used to exist around Mexico City. And then people would just harvest it off the top of the lake. Today we're a little bit further ahead of that, like a lot more purity, a lot more controlled cultivation of that. But for the past 30, 40 years, it's been typically done in like a large open pond. So we create artificial ponds, they refer to as raceways. They are located in a very warm climate, so you can get a lot of sun, and you can constantly have a water temperature between 85 and 90 degrees Fahrenheit, so really nice and warm. But they're still they're still located outside. You still have very little control over the actual cultivation methods. And today, what we do is then the next step in this process, where we grow indoors in a controlled environment with tanks that are completely enclosed. So we have really 24/7 control of what's happening inside. Plus, we also have full control over, making sure that no other types of algae, no leaves, no insects, no nothing can actually get into those tanks. Because in the end, you want to eat spirulina, and you don't want to eat a random blend of microorganisms that grow in a natural environment, but not in your food, hopefully. So that's where we are today.
That's great. So one of the themes that we talk a lot about on the show are some of the advantages and disadvantages of monoculture. So in a way, this kind of tank system is a form of monoculture. Are there any problems with disease that can pop up in microalgae? I know nothing about how these are farmed. Are there any problems when you grow them as like a single genetic source, like, or I don't know.
Yeah, I mean it's a good point, but the cultivation of algae and plants is very different, because
Yeah,
in nature, plants grow all over, and you have like food jungles, and typically you have lots of different plants growing next to each other, and biodiversity is good in that sense. But what we grow, they're microscopic. Like the difficulty that we would have is we cannot go and just like pick whichever ones we want, because they're just too tiny to do that. So we need to
yeah,
ensure we have purity of cultures, that we don't have other types of organisms. If you grow outside, whether that is completely natural in a lake, or whether that's in a controlled artificial pond, you may run into other types of algae that can grow in it. For sure, outside in the lake. I mean, it's a thriving ecosystem. That's what it should be. And even though there might be algae blooms, and then a specific strain is taking it over, you still have other things living in that environment. So it's really hard to separate those things. So in this case, we really want to ensure that there is monoculture, because we don't want to have other types of
contamination.
algae
Mhm.
that can produce toxins, or other algae that could potentially be harmful for human consumption in our cultures. And the interesting thing is that it's actually something that the algae enforces itself. Spirulina and the type of spirulina that we grow is an extremophile. It grows in a very high pH environment, and it's also very aggressive, which means that like it takes over the culture very quickly, and it like outcompetes everything else that's existing in this tank, which is in a natural environment a little bit more difficult, because that's considered an algae bloom. But for us, it's perfect, because we don't want bacteria, yeasts, or any kind of other types of algae growing in our systems.
Cool. So I'm sure many of the listeners are probably wondering, what does this look like? If imagine if we were going into one of these growing areas, can you paint a picture for us? Like what do these tanks look like? How does it all start? Is it just like a tank of water that all of a sudden becomes very blue or green, or what does it look like? And how do you know when these are ready for harvest? And how does that whole harvest process work with these very tiny organisms?
That's an excellent question. Let me talk about the blue and the green thing first, and then explain
Yeah.
how you grow this, because we see this a lot. That like, and I'm sure some of your listeners have seen the blue algae. That's like this super vibrant blue color. Sometimes it's called blue magic. Very good marketing term, by the way. But what it really is you take up a blue green algae, blue green because you have blue and a green pigment in it, chlorophyll, for the green and phycocyanin for the blue. And then you process it and remove chlorophyll, which Cassandra, is a really powerful antioxidant. Like you don't really
Yes.
want to take it out. And you highly process this stuff to end up with a green powder, which is not as nutritious as the original product. But hey, it's magic, so now it looks cool. I'm very careful about this stuff. I'm very much on the side of let's keep things as unprocessed as possible. Not completely against any kind of processing, but there's also no need to overdo it. And so that's the philosophy behind everything that we do here. And what that means for our cultivation is that we want to make sure that we can really ensure purity in the process, because we don't want to do downstream processing and we don't want to do too much to it afterwards. You can imagine our facility really as a crossbreed between a brewery and a vertical farm. If you haven't seen a vertical farm, they're like stacked like shelves, like the very tall shelves with like individual layers of cultivation on each shelf, the grow lights inside. And the difference for us is because we don't grow plants that grow above the water level and above the roots, our light shines straight into the water.
Okay.
So the hydroponic farmers out there will be like, oh my God, it's going to cause so much algae growth. Yeah, exactly. That's what we want to do here. We want to grow algae. So we have these flat tanks that are filled with a nutrient solution that provide all the benefits and all the nutrients that algae needs to grow. Then we have a starter culture inside. So we start with a light green water is the best way to describe it. So it's relatively diluted. We provide light, and then we infuse carbon dioxide, and there are other forms of carbon in the process as well. And then the algae grows, much like a plant would on in the soil. Algae grows in water, so it takes up the nutrients, it takes up the sunlight, it does photosynthesis, so it turns carbon into oxygen. We remove oxygen from the water in the process, and over time it turns darker and darker. Even though I don't like that comparison, it's a bit like the pond that's starting to turn when you have that kind of bloom, because that's what we want to do in a very controlled environment. So we measure the density. It's actually very easy to do that with like optical sensors, like see how light can penetrate. And then at a certain point, we harvest. And that means we take the water, we run it through several filters to these ultra fine 25 micron filters that take out this algae. And you end up with a watery, dark green, for the lack of a better word, sludge that's just thick, but still with a high water content. And from there on, we can do multiple things. So we press the algae at this point, so we remove excess water. So you end up with something that's about the consistency of hummus. So a mood that's dark green, like really dark green. And that's the starting point for everything that we do. And that's what is referred to as fresh spirulina. You have a paste that we sell by itself, or we turn that into frozen products to extend the shelf life a little bit, pre-portioned little cubes that are perfect more for like smoothies, if you make a little smoothie, something like that.
That's fascinating. I mean, I can really picture this. It is like an interesting cross between a brewery and a vertical farm. And so you're freezing the products, you're creating them into paste. And I guess I've gotten a little bit ahead of myself because we haven't got into yet like how We Are the Farmers was founded. So why don't we step back a second and tell me, like, what was the founding story and kind of what led you to this process? Because I think this is really fascinating. I mean, we've also just as a framework, we've also spoken with different companies that are working on other areas of kind of plant-based proteins, talking about pea proteins and soy proteins. And it's interesting to see how these non-meat sources of proteins. So what brought you to Spirulina and founding this company?
What do you mean? Would you be surprised if I tell you that I always wanted to be an algae farmer back home in Germany? Like that's
Was that your dream growing up? I don't know. That's
not anybody's dream when they're 8 years old. I used to be, that funny sides. I wanted to be a gardener, whatever that meant as a child. But like I always wanted to do something with plants. And well, that's also basically the story then how I got into this, because like 16, 20 years later, I was working for Olympus, as you said in my introduction, and while I enjoyed the work there, I was looking for something that was really more related to what I was passionate about. And I realized whenever I was coming home, I would be very deeply passionate about cooking and exploring new foods, and I would always grow some stuff, always have some tomatoes on the balcony or some basil on the windowsill at the very least. And I took just a lot of a lot of interest and a lot of joy out of the process of growing something and turning that into food that I eat myself. And at the same time, I studied engineering. I'm an industrial engineer, and I wanted to do something with tech. But up until that point, that was something that was very much contradictory, because I didn't want to be like in food tech and processing things, and like that didn't work for me. I always had this purity idea about food, and I learned about vertical farming at that point, and it was like, wow, okay, so you can combine your tech aspiration with your food and with what you like to do. And so that was my starting point of my journey. And I wanted to learn more about the food system. I learned about the issues that I mentioned in the beginning. And one thing in particular is the thing that resonated with me, or that made click, and was like, that's exactly what I want to work on. And that is the carbon footprint of a food system. Because that's one of the biggest issues that no one's talking about, that we actually have when it comes to climate change. About a third to probably even more of all man-made emissions are coming from agriculture and food. And unlike other industries like energy, for example, we don't really have scalable solutions to bring down our carbon footprint. We can, like, if I don't know, Elon Musk, or if Bezos and Gates would come around and be like, I put $10 billion down to bring our energy systems to renewables. We could do it. Like, we know how to do it. Like, it would be a bit more expensive, but we can figure this out. And that's not true for food, because we're extremely dependent on the two sides of this. We're extremely dependent on animal proteins around the world, and that's making up 50% of all food emissions. So out of these, like 30% overall, 15%, like 10 to 15% of all globally man-made emissions are coming from animal husbandry. And the problem is we don't really have a way out of this, because we need to produce protein. It's highly unlikely that within the next 10 years, the entire world is going to go vegan, or at least vegetarian. That's not going to happen, especially in developing countries. And then you have a few other options, right? You have alternative proteins. You have, I should say, alternative meats rather than proteins, because you have the Beyond Meats, the Impossible Burgers. And they're nice, and they're solving some issue, but they're not as, like, they're not good for us. They're not as nutritious, and also they are not necessarily that much better from an environmental perspective. They're better than beef, but they're still not carbon neutral in any way. And then you have like the lab-grown meats and that kind of stuff, and that will still take another 10 years to actually be available around the world in an affordable way. And then the question is, do people actually want to eat this? Like, do you want to eat something that's grown in a lab, in a petri dish? And I'm sure there will be people, and it will fit into a specific group of folks. I'm not sure if it's going to take over as easily as some people make it seem.
Yeah, there's some problems too with like cell culture. I mean, I do a lot of cell culture in my lab for scientific research, and you need animal like materials like fetal bovine serum, which is like fetal cow blood juices. It's basically the way the best way to explain it, to grow those things. So like they're not like, it's very difficult to completely remove animals from that product chain. And as you said, the carbon neutrality issue, for example, with pea proteins, you have peas, different stages of the pea cultivation or the protein extrusion. Those materials are getting shipped back and forth across the globe as part of the process. So like that's a problem when it comes to carbon neutrality. Yeah.
And not against any of those solutions. I'm just saying none of them are going to be enough to actually get us there.
Yeah.
And then the second big component is that we're still so dependent on fossil fuels throughout the entire supply chain in agriculture. All of our fertilizers are derived from natural gas. All of our pesticides are derived from fossil fuels. Like if we think about just from a physical energy production system, all of this is derived from coal, gas, and oil. Instead of electrified. Like we cannot even switch it over to renewable energy immediately because we need these inputs to feed people. So we're really in a very bad spot here, and we don't really realize it that much. And that's where I'm going back to the beginning. Hell, so what do we do? Like, how do we actually get there? And so I started doing some research, and I came across microalgae. And microalgae are just these super fascinating organisms that grow super fast. They don't need arable land, so we don't have deforestation issues. We don't need that much fresh water, which is great because that's also a huge crisis that not enough people are talking about. Then we can actually have a very low carbon footprint. Dependent on cultivation methods, you can actually feed carbon into the cultures. So you actually increase the carbon input, and you can actually cultivate with a very low to zero carbon impact. So awesome. We just have to find a way to make people eat it, and that's how we approach this. And how can we actually make microalgae something that is as simple for people as possible and as exciting as possible? So we incorporate that in more and more foods.
So tell me, so we're talking about you have these products, you have fresh product. Can you describe for us what would just eating fresh pressed microalgae actually taste like? What does fresh spirulina taste like? Is it fishy tasting? Is it like, or like I have no idea. I have never eaten this before. So paint me a palate picture
Yeah,
of what it would be
fair
like.
point. And the nice thing about microalgae is it's relatively neutral. Like I like to describe the flavor of fresh microalgae as mineral water. Like if you just taste it by itself, you get the mineral flavors. You know that there's a lot of like iron and sodium and a little bit of potassium and so on in there, and you can taste that. But the moment you blend this into anything, you don't taste this anymore. It does have a very interesting and exciting texture. Like when we give this to chefs, they're usually very excited because it's a very rich and creamy texture that's not fat-based, it's protein-based. So it coats your mouth in a very nice way, and it's very exciting to work with. And it, like if you add it to let's say a smoothie at home, it's a bit like yogurt or frozen banana. It gives a lot of thickness and creaminess to your smoothie. So from that perspective, it's really nice. But we're really talking about a blank canvas that can be used in a variety of different ways, and that is a protein source that is also an excellent source of micronutrients that is also completely unprocessed.
It's great. So what are the some of your favorite ways to eat this? Like do you is there something beyond smoothies, or like you described it as almost like a hummus. Like could you eat it like a hummus? Like yeah.
Totally. Yeah, there's so many different ways of using it. Like my go-to is simply because I have a smoothie every morning. I add it to my smoothie, but I know that, for example, my co-founder loves to put it on a little bit of toast, adds a little bit of salt on top and a little bit of lime or lemon juice, and has that as a breakfast. It really works well also in all kinds of breakfast foods like overnight oats and scrambled eggs in a yogurt bowl. We made fantastic pesto with it. You can make salad dressings in with your hummus. If you make a hummus or a guacamole is green anyway, so you can make an extra green guacamole. So they're like it's the starting point is really your imagination and your creativity. It's a paste that can be easily incorporated into a lot of different things. Yeah.
That's great. So as we wrap up, I guess one big question I have for you is, what is your future vision for spirulina? Like let's say 10, 20 years down the road, where do you hope that this food source might be, what its place might be within our food system?
Yeah. So just recently, I came across a study from a major institute in the United States that was saying that they expect that by 2050, about 15 to 20% of all globally consumed protein will be algae derived. And since most of the seaweeds that we know aren't really high in protein, we're really talking about microalgae here. And that is super fascinating because it means that we will figure out a way to incorporate that into all kinds of foods. And we already do, by the way, like we already incorporate algae in so many foods. We just don't know about it. Like algine is one of the most common emulsifiers. If you had yogurt, if you brushed your teeth, you likely had algae in there. It's a very common ingredient that people are not familiar with, and that is true for fresh algae as well. And I believe that we will find ways to incorporate that in so many different things so that we can't even imagine right now. It will be an ingredient in your veggie patties. It will be potentially, it might even be an ingredient in your lab grown meat that you mix in. So you have one part lab grown meat and one part algae, and you have this new minced meat situation that you can use that is super nutritious but also rich in protein and also tastes like meat. So there are many ways in which we can think about this, but what is really the important thing is that we produce more of it. So if you ask me what's my vision, I want to build the largest indoor spirulina farm, or I should say largest indoor microalgae farm in the entire United States, so that this stuff is going to be widely available, that it's affordable for everyone, and that we can actually have a nutritious, sustainable, and protein-rich path into the future.
Oh, that's amazing. I like that vision. I like also how it could be disseminated to different cities. I mean, you could have like algae hubs, right? To feed to grow locally. Well, before we go, I just was thinking of one other thing I'd like to show the listeners that do tune in to the show on YouTube, and that would be, would you mind showing us some of your products? I think you may have some in the freezer.
Absolutely. Let me grab it real
Yeah,
quick.
okay, great.
All right, fresh from the freezer.
Awesome.
These are our jars. It's actually a prototype model, so it doesn't even have our standard label here on the top like all the other ones. But they all come with like these cute little stickers because what we do is we ship the jar, and it's made out of plastic, which I don't really like, but for freezer food, it's really the best way. And then all subsequent shipments are going to be in refill bags. So we encourage you to keep that one with a bunch of stickers, like you put on your water bottle or something, and make it your own. And then what we have inside are these like frozen cubes of spirulina.
Oh, cool. How
One
large
inch,
are those? Like an
they're
inch?
about an inch,
Mhm.
inch by an inch by an inch. They're 12 grams each, and well, they just pop into your blender when you make a smoothie, and they're like about the same amount of nutrients as 2 cups of leafy greens. So they're like super packed with nutrients. Two of those
Wow.
cubes, same amount of protein as an egg. So they're like really good source of protein, really good source of micronutrients. As I like to say, no planets have been harmed in the making of this cube. This is sustainable, and yeah, I love them.
That's great. Well, Jonas, where can we direct our listeners to learn more about these products and your company? Is there a website we can send them to?
Absolutely. So, best way to actually learn more about us is on our website. Our company name is We Are the New Farmers, the whole thing, mission statement and name. And our website is new-farmers.com. So if you type that in, you get straight to our website. You can also find us on all social media, TikTok, Instagram, the handle We Are the New Farmers. And yeah, and also at a bunch of events in New York City if you happen to live in New York City.
That's great. So, do you have any upcoming events this summer you wanna highlight?
So we just ended up with our vegetarian food festival, so I can't tell people about that anymore. But we're going to be at multiple farmers markets across Brooklyn and Park Slope, as well as in Greenpoint for the folks local, and you can meet us there every Sunday.
That's fabulous. Wow. Well, thank you so much, Jonas, for sharing these insights into spirulina. I mean, I think I need to definitely try this because I don't know how I haven't had spirulina yet, but I think it's time. And I want to go with the fresh stuff, not the dry powder from what it sounds like.
That's the
So
right way. Like I know you you dig a lot into studies, you will see there's a bunch of stuff out there how good it is, and I think it's just a matter of making people aware of it and getting this out of there because it's such an amazing food, and we definitely need more of this.
Absolutely. Well, thanks again. All right, foodies, you've been listening to Foodie Pharmacology, the science podcast for the food curious, recorded today on a Streamcast. I want to thank all of you listeners for tuning in each week to hang out with us. I want to also send a special shout out of thanks to our producers, to Rob Cohen and Christine Roth of Co-Conspiracy Entertainment, for producing an excellent show every week with us. I want to also remind you, you can find this episode and all of our others on our website at foodiepharmacology.com. And you can check out the video version of this episode on our YouTube channel at Teach Ethnobotany under the Foodie Pharmacology playlist. I'm going to be hitting the road this summer, traveling to a lot of different places, ranging from Jamaica to Albania and Kosovo and the UK and Italy and then Alaska and New Hampshire. I'm going to be all over the place. So I'll be bringing you shows from some very interesting locations on site this summer. So be sure to hit that subscribe button if you haven't already so you don't miss any of these really cool upcoming episodes. Thanks so much for listening. Stay healthy out there, and I'll see you next time.